Runge-Kutta is simply a numerical method for solving differential equations. Its equation is as follows. Yn plus 1 is equal to yn plus the product of k1 plus 4k2 plus k3 and h over 6, where h is the step between the initial and final values of x. Yn is the initial value of y, and yn plus 1 is the final value of y. But what are k1, k2, and k3? To understand them, we need to recall that the slope of the function, or simply f dash, is equal to delta y over delta x. On rearranging the equations, we find that delta y is equal to the product of f dash and delta x. This means if we have a starting point y node, we can get another y at a certain value of x by using this concept. This is basically how k1, k2, and k3 work. They are all simply slopes of the function at different points. If we dive more into it, you can find that k is equal to f of x node and y node, where f is basically y dash, the slope of the function at the starting point. K2 is f x plus h over 2 yn plus h k1 over 2, which is the slope of the midpoint between the initial and final points. And K3 is the slope of the curve at the final point. But if you look at the example curve shown here, you can notice that the difference in y's is not constant for moving at a constant rate of x. To compensate this matter, we add or subtract the k1 and k2 values to reduce the error. If you return to the main equation, you see that we have k1, which is the starting slope, then we add k2 and k3 to reach the final point. But we add 4 of k2 as it being the most accurate slope out of the 3. And also this compensates the error in k3. Similarly, we can use the same concept for solving higher order of differential equations.